Good afternoon, good evening, and good night. This is our project that we have been working on in the systems course. You can notice on the left side of the simulation done on Simulink, we have two sliders changing the value of the resistance of the two LDRs we have put in the voltage divider. By changing these values, which I'm gonna do now, the two voltages resulting from the two voltage dividers are gonna change. We are gonna take the difference between those two voltages, pass it through an absolute circuit, which is gonna take the absolute value of the difference between the two voltages resulting from the two voltage dividers, and it's gonna pass this positive signal. It's gonna be only positive. It's not gonna be negative because we have passed through this absolute circuit. We're gonna pass this signal to the PWM, to the PWM port, to the control pin on the second 555 timer. After doing so, we're gonna take the signals that are coming from the voltage divider through two different paths, where we are gonna do some signal conditioning, Schmitt triggers, which is gonna provide us with a dead band to avoid jittery movement or any noise in the lighting. We need the motor to be able to sustain stability when the solar panel is pointed to the sun. These two paths, which are down, are gonna go to the H bridge, and is gonna determine the direction in which the motor is gonna move. PWM part is responsible for the determination of the speed in which the motor is gonna move it. The first scope display is for the wave or the signal coming from the clock, or the first 555 timer in astable mode, which we managed to assemble with a frequency of 60 Hertz with a very tiny load time. This very tiny load time is crucial for the correct function of the second 555 timer, which is in monostable mode, which is responsible for the generation of the PWM signal, which is done by measuring or by controlling the control voltage going to the second 555 timers. The second scope display is for the final signal going to the motor. The motor is sensing the average value of the incoming negative and positive PWM signal, which you can know by calculating the duty cycle and multiplying it with the source voltage connected to the H bridge. This is our team: Yusuf Kamil, David Amir, Moraya Ayman, Michael Ihab, Moraya Sami, George Magid, Emma Sharif, Verena Hani, Mina Muhib, Yoanna Lotfi, and me, George Wanis.